The map you learned in school is wrong. Tornado Alley, that famous stretch of Texas, Oklahoma, and Kansas, is on the move. Over the last 40 years, it has crawled hundreds of miles east into a region that is darker, more crowded, and far deadlier. You may already be living inside it. We will chase the science behind the shift, the storms that hide inside the rain, and the night everything changed. If this grips you, like and subscribe. Buckle up. Here we go. Picture the middle of America from high above. A wide band of flat grassland runs up the center of the country, from Texas through Oklahoma and into Kansas. For most of the last century, that band had a nickname. People called it Tornado Alley. It earned the name the hard way, by producing more tornadoes than almost anywhere else on Earth. The story everyone learned was simple. Spring arrives, warm air rushes up from the Gulf, cold air spills down from the Rockies, the two crash together over the plains and the sky begins to spin. Storm chasers point their cars west toward Kansas. News crews stake out the same open fields year after year. The image got burned into our minds. Tornadoes belong out there, on the empty grass, where you can watch them coming for miles. That image is now a museum piece. Somewhere in the last 40 years, without any announcement, the twisters began to wander. They did not stop hitting the plains. They started showing up somewhere else, more and more often, in places the old map never marked in red. The danger did not vanish. It packed up and moved to a new address. And here is the part that should stop you cold. The new address is full of people, not empty grassland at all. Towns, suburbs, forests, mobile homes, families asleep in the dark. The storms are drifting toward the exact places least ready to survive them. For a long time, nobody noticed. Tornadoes are chaos by nature. One bad year in one state means nothing on its own. A quiet year somewhere else could just be luck. To see a pattern, you need decades of records and someone patient enough to stare at all of them at once. You need someone willing to ask a strange question. What if the alley itself is not standing still? Most people never asked. Why would they? The map had looked the same their whole lives. The word Tornado Alley meant the plains, the way the word desert means sand. Changing that felt almost impossible. Then the numbers started whispering a different story. Fewer red dots out west, more red dots to the east. A slow, quiet drift that only shows up when you line up the years and watch them move. The plains still get their monsters. Kansas will always know the roar. But the center of gravity, the place where the worst risk now lives, has slid off the old map and onto ground that was never supposed to be the target. Think about how strange that is. A tornado is a thing of a single afternoon, born and gone in minutes. Yet gather 40 years of them, and together they trace a path of their own across the country, a slow migration hidden inside all that chaos. Only the whole swarm, seen across decades, shows the drift. And that drift, gentle in its pace, is brutal in its meaning. Every mile the risk moves east. It moves toward denser towns, thicker forests, and flimsier homes. To understand how big this is, we have to meet the person who first refused to look away. One scientist staring at 40 years of storms, noticing something everyone else had missed. What he found did not just redraw a map. It moved a bullseye onto millions of people who still think they are safe. Victor Gensini teaches meteorology at Northern Illinois University in a town called DeKalb, out on the flat edge of the Midwest. He grew up loving storms the way some kids love dinosaurs, but loving storms and proving something new about them are two different things. To prove something, you need data, lots of it, and you need the nerve to trust what it tells you, even when it contradicts everything the textbooks say. In 2018, Gensini published a study that quietly rattled his field. He had done something patient and unglamorous. He gathered tornado reports going back to 1979, 4 decades of them, and instead of asking only where twisters had touched down, he asked a deeper question. Where were the conditions ripe for them? Where was the atmosphere loading the gun, even on days when nothing fired? That second question mattered more than it sounds. Tornado reports are messy. More people with phones means more sightings. A storm over an empty field might go uncounted, while the same storm over a town gets 100 videos. If you only trust the reports, you can fool yourself. So Gensini looked past the reports to the machinery underneath, the heat and the wind and the moisture that build a tornado in the first place. When he lined up the years, a shape appeared, and it was moving. The favourable days, the loaded skies were thinning out over the classic plains. At the same time, they were multiplying to the east, over the Mississippi River Valley in the deep south. The engine of tornado weather was sliding across the country like a shadow crossing a lawn. Gensini did not shout that he had solved everything. Good scientists rarely do. He laid out the trend, showed his work, and kept watching. Because a single study is a snapshot. A trend is only real if it holds. So he stayed on it. Year after year he checked whether the drift continued, or whether he had simply caught a strange stretch of weather. And year after year the answer came back the same. The activity kept leaning southeast. He has said plainly that the shift is still there, that the risk is more prevalent in the southeast now, and that fresh evidence lands every single season. Think about what that means. This is not one paper from years ago gathering dust. This is a living pattern, confirming itself in real time with every new spring and every new outbreak. What makes Gensini's work land so hard is that he refused the easy comfort. It would have been simpler to say the plains are the plains, the map is the map, nothing to see here. Instead, he treated the atmosphere like a crime scene and followed the evidence wherever it went. The evidence went east, and that raised a harder question, one that turns a curiosity into an emergency. If the storms are moving, are they moving toward more people or fewer? Towards safer ground or more dangerous ground? We will get to that answer, and it is grim. But first we have to see the raw numbers for ourselves, because the size of this shift is almost hard to believe. We're talking about a distance so large it would swallow whole states, a migration measured in the width of the country itself. Here is the number that stops meteorologists in their tracks. Over roughly the last 40 years, the heart of tornado activity has shifted between 400 and 500 miles to the east. Let that distance settle. That is not a nudge. That is the span from the dry plains of northeastern Texas all the way into eastern Missouri, Arkansas, western Tennessee, and northern Mississippi. It is like watching a mountain range get up and walk to a different state. Picture standing in Oklahoma City. Now picture a place 500 miles east of you. You have crossed most of the country's midsection. That is how far the danger zone has slid. The pattern hides inside two simple trends running in opposite directions. In the traditional plains, the number of days with tornado-friendly skies has been falling. In the mid-south and the southeast, that same number has been climbing, and climbing sharply, especially east of the Mississippi River. One region cools off, the other heats up. The seesaw tips east. Research published in a leading climate and weather journal compared long stretches of the record, going back to the middle of the last century. The verdict matched what Gensini had found. Tornado activity has been draining out of the Great Plains and pooling in the Midwest and the South. Fewer twisters where we expected them, more where we did not. But the shift in place is only half the strangeness. The storms also changed their rhythm. They started clustering. Instead of scattering evenly through the season, tornadoes now tend to arrive in fewer days but in bigger, meaner bunches. A calm week, then a single day that spawns dozens of them at once. Imagine rain that stops falling gently and instead dumps a month's worth in one afternoon. That is what is happening to tornadoes. The total may hold roughly steady, yet the way they arrive has turned violent and lumpy. And a day that produces 30 tornadoes at once overwhelms warning systems, hospitals and rescue crews in a way that 30 scattered twisters never would. There is one more twist buried in the data, and it changes everything about who gets hurt. The year-to-year swings have grown wilder. One season stays oddly quiet. The next erupts. That unpredictability is its own kind of danger, because it lulls people to sleep. A few calm years convince a town that the threat has passed, right up until the sky turns green. Now, honesty matters here, and the master rule of good science is to state the limits out loud. This shift is real, but it is a slow tilt, not a sudden jump. Tornadoes have always struck the south. They always will strike the plains. Nobody is claiming Kansas is now safe or that Texas is off the hook. What the numbers show is a change in balance, a lean, a centre of gravity sliding east across decades. But a slow lean can still be deadly when it points at the wrong ground. A 500-mile drift toward empty prairie would barely matter. A 500-mile drift toward crowded towns and forests and mobile homes is a different story entirely. So where exactly did the bullseye land? It landed on a region with its own dark nickname, one that most people outside the South have never heard. A belt that has quietly outkilled the famous plains for decades, hiding in plain sight. In 1971, a forecaster named Alan Pearson gave a warning that took 50 years to fully arrive. Pearson ran the National Severe Storms Forecast Centre, the office that would later grow into the nation's Storm Prediction Centre. He had noticed something that unsettled him. There was a second region, down in the southeast, that produced fewer tornadoes than the famous plains, yet somehow buried more people. He gave it a name, Dixie Alley. The name never made it into the school books. Most Americans have heard of Tornado Alley. Far fewer have heard of Dixie Alley, even though, storm for storm, it has long been the more dangerous of the two. Where is it? The core sits over Mississippi, Alabama, Arkansas, Louisiana, and Tennessee. The edges reach into Georgia, Kentucky, the boot of Missouri, upstate South Carolina, and the western slice of North Carolina. Draw that on a map and you are covering the homes of tens of millions of people. The states in this belt do not mess around. Mississippi averages around 115 tornadoes a year, the most of any state in the region, and roughly 5 times the typical state's share. Alabama runs close behind at about 90 a year. These are not quiet corners of the country, they are storm factories. But here is the piece that makes Pearson's warning ring across the decades. Dixie Alley produces fewer tornadoes than the plains, and still it kills more. Read that again. Less quantity, more death. The math should not work, yet it does, year after year, with brutal consistency. Why? Because a tornado is only half the equation. The other half is what the tornado hits and when, and who is awake to hear the warning. The plains offered the storms open fields and daylight. Dixie Alley offers them forest to hide in, darkness to strike in, flimsy homes to flatten, and crowds of people directly in the path. Same wind, wildly different outcome. Think of it like 2 identical fires. One starts in a bare stone courtyard, the other starts in a crowded wooden theatre with the lights off. The fire is the same size in both. Only one becomes a catastrophe. The plains were the stone courtyard. Dixie Alley is the darkened theatre. For 50 years this belt did its deadly work in relative quiet, overshadowed by the glamour of plains storm chasing. The cameras pointed at Kansas. The killing happened in Alabama and Mississippi and Tennessee, often after dark, often in rain, often in homes with no basement to hide in. And now, the very trend we have been tracing is pouring more storms into this belt. The eastward drift is aiming straight at the deadliest tornado region in the country, feeding it and loading an already loaded gun. The place that historically punched above its weight in fatalities is being handed even more storms to work with. Pearson saw the danger in 1971 with nothing but instinct and scattered records. He could not have known that a warming world would one day shove the entire alley in his direction, turning his footnote into the main story. To understand why these southern storms hit so much harder, we first have to understand the storms themselves. What actually happens inside the clouds to birth a tornado? What invisible machinery turns an ordinary summer sky into a killer? The recipe is stranger and more delicate than you think, and every ingredient in it is now shifting. A tornado looks like pure chaos, a wild rope of wind ripping across the ground. But it is born from something almost like a recipe. Get the ingredients right, in the right order, and the sky assembles a killer. Miss one, and you get nothing but a grey afternoon. The first ingredient is fuel. Warm, wet air sitting near the ground. The Gulf of Mexico is the great supplier here, breathing moist heat northward across the land. This air wants to rise the way a hot balloon wants to climb, because warm air is lighter than the cooler air above it. The second ingredient is a lid, then a trigger to break it. Often a layer of drier, cooler air sits on top, holding the warm air down like a pot lid holds down steam. Pressure builds underneath. When something lifts that lid, a front, a boundary, a nudge of rising ground, the trapped warm air explodes upward in a towering rush. Scientists measure that pent-up energy and give it a name that just means the potential to rise fast. The more of it, the more violent the updraft. Those 2 ingredients build a thunderstorm. But a thunderstorm is not a tornado. For the sky to spin, you need the third and strangest ingredient, wind shear. Wind shear means the wind blows differently at different heights. Slow near the ground, faster up high. From one direction low, from another direction aloft. Picture rolling a pencil between your palms, one hand pushing forward, the other pulling back. The pencil spins. Now imagine that spin happening in a tube of air the size of a small town, lying flat like a rolling log across the landscape. That horizontal spin is invisible and harmless on its own. Then the powerful updraft arrives, punches into that spinning tube and tilts it upright. The rolling log stands on end. Now you have a column of rotating air inside the storm, a spinning heart that meteorologists call a mesocyclone. A storm with this rotating core has graduated. It is a supercell, the most dangerous kind of thunderstorm on the planet, and the parent of nearly every violent tornado. Here is the part that makes it beautiful and terrifying at once. As that column of spinning air gets stretched taller and thinner, it spins faster. It is the same trick a figure skater uses. Arms out, slow spin. Arms pulled in tight, the skater whirls into a blur. Stretch the vortex, narrow it, and the wind speed screams upward until a funnel drops from the cloud and reaches for the earth. Every one of those ingredients has to line up in the same place at the same time. Fuel from the Gulf, instability to launch the air skyward, shear to set it spinning. Miss the timing and the storm falls apart. Nail it, and you get a machine that can level a town in seconds. For a century, the plains served this recipe better than anywhere on Earth. The geography lined the ingredients up like a factory line. But the recipe is not loyal to the plains. It follows the ingredients. And every single one of those ingredients, the Gulf moisture, the dividing lines, the winds aloft, is being nudged eastward by forces we're only beginning to grasp. The first of those forces is an invisible wall that once stood guard over the plains, a boundary you cannot see, but which used to decide exactly where the storms would fire. Somewhere over the middle of the country, an invisible wall rises into the sky every spring. You cannot see it. You cannot touch it. But it decides whether tornadoes are born, and for a long time it stood almost exactly over the classic tornado alley. Meteorologists call it the dry line. The dry line is a boundary between two vast bodies of air. On the west side, hot and bone dry, air baked over the deserts of the southwest and the high plains. On the east side, warm and heavy with water, air carried up from the Gulf of Mexico. These two masses do not mix gently. They press against each other like two crowds shoving at a door, and along that seam, the sky loves to detonate. When the dry air, which is denser, wedges under the moist air and forces it upward, it acts like a plough lifting the lid off that trapped Gulf moisture. The warm, wet air shoots skyward. Storms fire in a line right along the boundary. For generations, that line sat over Texas, Oklahoma, and Kansas, which is a huge part of why the plains became the tornado capital of the world. The trigger and the fuel met right there. Now hold that image, because here is where it turns unsettling. That wall is not bolted to the ground. It drifts. It slides east and west with the seasons, with the droughts, with the moods of the atmosphere. And over the long haul it has been creeping in one direction. Since the late 1800s, the average position of this dividing boundary has shifted roughly 140 miles to the east. Think about that. The invisible wall that decides where storms fire has walked 140 miles across the map, the distance of a long day's drive, and it has walked the same way the storms are walking, east. When the trigger line moves east, the storms that fire along it move east too. The factory does not close, it relocates. And the new location sits closer to the forests and towns of the Mississippi Valley than to the open grass of the high plains. Why would an invisible wall pack up and move? The answer lies in what feeds each side of it. The dry western side is fed by the deserts and the parched high plains. The moist eastern side is fed by the Gulf. If the west grows drier and its hot air pushes harder, and if the Gulf grows warmer and shoves more moisture inland, the seam between them shifts. The tug of war has a new balance point, and it lands farther east than it used to. That is the quiet engine behind so much of this story. It is a slow redrawing of the invisible lines that organize the sky, one quiet degree at a time. Move the boundary, and you move the storms. Move the storms, and you move the risk onto new ground. But the dry line is only responding to something larger. Something has been drying out the western half of the country for years, starving the old alley of the moisture it needs, and building a dome of heat so stubborn that storms cannot form beneath it, To see why the plains are going quiet, we have to fly west, into the heart of a drought that has lasted longer than almost any in 1,000 years. Fly west, over the deserts of Arizona and New Mexico, and out onto the high plains, and you are flying over land that is thirsting. For more than 2 decades, the American Southwest has been locked in a drought so deep and so long that scientists reach for a rare word to describe it: megadrought, the kind of dry spell that lasts for a generation. In recent years, huge swaths of Arizona have sat in the 2 worst categories of drought the country tracks. The levels labelled extreme and exceptional. Reservoirs shrink, rivers thin to trickles, and the soil, baked and cracked, loses the one thing that makes tornado weather possible: moisture. Now, why would a drought in Arizona have anything to do with tornadoes in Kansas? The connection runs through the air, and it is elegant and merciless. When land dries out, the sun's energy has no water to evaporate. Normally, some of that heat goes into lifting moisture off the ground. On parched land, that pathway closes, so the energy pours straight into heating the air instead. The dry ground bakes, the air above it swells and rises, and a mound of high pressure builds over the region. Meteorologists call it a ridge, or a dome of high pressure. You may know it by its summer nickname, the heat dome. A dome of high pressure is the enemy of storms. Under it, the air sinks instead of rising. Sinking air warms and dries as it descends, capping the sky, smothering the updrafts before they can grow. It is like sitting on the lid of that boiling pot and refusing to let go. Nothing can climb, nothing can fire. So over the drying western plains, storms that once would have exploded now get squashed. The dome sits there like a bouncer at a door, turning away the very weather that made Tornado Alley famous. The energy does not vanish, though. It gets pushed to the edges of the dome, shoved downstream, forced to find somewhere else to rise. And where does it go? East. Around the eastern flank of that high-pressure ridge, storm systems get steered toward the Mississippi Valley in the southeast, where the lid is thinner and the fuel is richer. The drought in the west does not just quiet the plains. It actively deflects the action toward Dixie Alley, like a boulder in a stream splitting the current and sending it rushing down a new channel. This is the hidden hand behind the shifting map. A drought 1,000 miles from the storms is helping decide where those storms are allowed to be born. The west dries, the dome builds, the action slides east. It is a chain of cause and effect stretching across half a continent, and most people caught in the new bullseye have never heard a word of it. There is a grim symmetry here. The same warming that deepens the western drought is also loading the eastern side of the equation, warming the waters that feed the storms their fuel. The plains lose their moisture, the southeast gains extra, the seesaw tips harder. To feel the full weight of that tipping, we have to turn to the sea itself. Because just south of Dixie Alley lies a body of water that has been running a fever, and every extra degree of its heat is being poured straight into the storms. South of the coastline, the Gulf of Mexico spreads out warm and blue, and it has been getting warmer. On average, its surface now runs about 1 to 2 degrees Celsius hotter than it did around the middle of the last century. In the everyday numbers most Americans use, that is a couple of degrees Fahrenheit. It sounds like nothing. A rounding error. A difference you could not feel with your hand. Gensini has a way of shattering that false comfort. He asks you to think about water freezing. The gap between 32 degrees and 33 degrees Fahrenheit is also just 1 degree. Yet on one side of that line you have solid ice, and on the other you have flowing water. A single degree decides whether a lake is a skating rink or a swimming hole. Small numbers near a threshold change the whole world. The Gulf is that kind of threshold system. Warmer water evaporates faster, loading the air above it with more moisture and more heat. That air is the fuel for every storm downwind. So when the Gulf warms even a little, it hands the sky a richer, more explosive supply of energy. The storms that feed on it grow taller, meaner, and more capable of spinning. Warmer water also means the fuel stays available longer into the cold months, and this is where it turns frightening. A Gulf that stays hot does not shut down for winter the way it used to. It keeps breathing warm, moist air northward even in December, even in January, keeping the sky primed at times of year when families assume the danger is over. We saw exactly this in one of the deadliest recent outbreaks. On the December night it struck, the Gulf's surface was running close to 5 degrees Fahrenheit above normal. That extra warmth sent a river of humid, unstable air surging north into the Mid-South, in the dead of winter, and the sky responded with monsters. We will return to that night, because it may be the clearest warning we have ever been handed. Picture the Gulf as the gas tank for the whole tornado machine. For a century that tank was full mostly in spring. Now it is topping off earlier, staying full longer, and holding more high-octane fuel than before. The engine downwind can run harder, in more months, over the region sitting closest to the coast. And the region sitting closest to that warming coast is Dixie Alley. This is why the eastern side of the story matters as much as the drought out west. The plains are losing moisture, the southeast is being handed extra, one region gets starved, the other gets overfed. The imbalance does not just move the storms, it energizes them right where the most people live. And notice how the pieces are locking together. The western drought builds a dome that deflects storms east. The warming Gulf pumps extra fuel into that same eastern ground. The invisible dry line drifts toward the fuel. Every arrow points the same direction, toward the forests and towns and mobile homes of the south. But there is still one more mover in this machine, high above our heads, a fast river of air that steers where storm systems travel. And it too has begun to bend its path in a way that funnels the worst weather straight into the new alley. 7 miles above your head, a river of air races across the country from west to east. It is the jet stream, a ribbon of wind so fast it can top 100 miles an hour, and it is the great steering wheel of American weather. Storm systems ride along it like leaves swept down a current. Wherever the jet stream goes, the storms tend to follow. Most of the time we forget it is there. But the jet stream is not a straight line. It buckles and waves, dipping south in some places, bulging north in others, like a rope shaken loose. Where it dips south, it drags cold, energetic air down with it. And lately, it has been dipping south in a very particular place. Down into the lower Mississippi Valley, into the Delta country, right on the doorstep of Dixie Alley. This is where all the pieces we have gathered snap together. Remember the dome of high pressure baking over the drought-stricken southwest. That dome does more than smother storms beneath it. It forces the jet stream to swerve around it. The fast river of air cannot punch straight through the ridge, so it slides up and over the top and then plunges down the eastern side, diving south into the very region already loaded with Gulf moisture. Picture a boulder dropped into a stream. The water cannot flow through the rock, so it splits and rushes around it, carving a new path along the far bank. The high-pressure dome is that boulder, the jet stream is the water, and the far bank, where the current now digs hardest, is the Mississippi Delta and the deep south. When that fast, cold air aloft plunges over warm, moist air near the ground, you get the exact clash tornadoes crave. Cold and dry on top, warm and wet below, with strong winds racing at altitude to provide the shear that sets the sky spinning. The jet stream diving south does not just deliver storms to the region. It supplies the wind shear that turns ordinary thunderstorms into rotating supercells. And here is a cruel bonus. A strong plunging jet stream in the cooler months moves storms along faster. A tornado riding a winter jet can barrel across the ground at highway speeds, chewing up mile after mile before anyone can react. The faster the steering current, the less time a town gets between the warning and the impact. So stack it all up. The western drought builds the dome deflects the jet stream south, the diving jet stream carries storms and shear into the deep south. The warming Gulf waits there with a full tank of fuel. The drifting dry line marks the spot. 4 separate forces spread across half a continent, all conspiring to point the tornado machine at the same crowded, wooded, unprepared ground. None of these forces is loud on its own. A drought, a warm sea, a bend in a high wind. Alone, each is just weather. Together, they redraw the map of danger for a nation. And they do something else, something that catches families most off guard of all. By shoving the action into the cooler months, they break the oldest assumption in the book, the assumption that tornado season lives only in spring. Because the new alley does not wait for April. It can strike in the dead of winter, in the dark of a December night, when nobody is watching the sky. For as long as anyone could remember, tornado season had a calendar you could set your watch by. Spring, April and May. The plains would warm, the storms would build, and everyone from Texas to Nebraska knew to watch the sky in those 2 months. Come summer, the threat faded. Come winter, you could almost forget it existed. The season had rules. The new alley tore up those rules. As the action slid east, it also slid across the calendar. In the traditional plains, the number of tornadoes in the classic spring months has been slipping. Meanwhile, east of the Mississippi, something unnatural has been growing. Winter tornadoes. Twisters in the months when the ground should be cold and the sky should be quiet. Places like Kentucky, Illinois, and Indiana have seen more and more cold season outbreaks, storms arriving in the dead of the year. The Deep South now runs on a broken clock with 2 alarms. One peak comes in late winter and early spring, roughly February into mid-April. Then, months later, a second peak returns in the fall. 2 dangerous windows instead of one, bracketing a calendar that used to have a single, predictable danger zone. Why would the cold months turn violent? Because the fuel no longer takes the winter off. Remember, the Gulf stays warm later and later, and the diving jet stream is strongest when the seasons turn cold. Put a warm, moist Gulf together with a powerful winter jet stream, and you can build tornado weather in January as surely as in May. And winter tornadoes carry a hidden cruelty. The days are short, so darkness falls early, which means more of these storms strike after sunset, when families are asleep. The winter jet is faster, so the storms race across the ground quicker, stealing precious minutes of warning. A cold season tornado is more likely to come in the dark and more likely to come fast. 2 strikes against survival before it even touches down. Now think about how people prepare, or fail to. Generations of families learn to brace for spring, school drills in April, a watchful eye in May, then relax. That old rhythm is a trap now. A town that only worries about tornadoes in spring is a town wide open in December. The threat did not just move across the map. It moved across the year, into months when nobody is looking. Picture a lifeguard who watches the water only in July, because that is when swimmers used to drown. Now people are swimming in January, in the cold and the dark, and the lifeguard's chair is empty. That is the danger of a season that broke its own rules. The habits that once kept people alive now leave them exposed. This is one of the most underrated parts of the whole shift. We talk about the storms moving hundreds of miles east, and that is dramatic enough. But they are also moving weeks and months across the calendar, arriving when guards are down and shelters are unstaffed, and the very idea of a tornado feels absurd. The boundaries of place and time are both dissolving, and behind that dissolving, there is one more line on the map that is quietly walking east. A line so old that explorers drew it more than a century ago to divide the wet half of the country from the dry. That ancient dividing line is on the move too, and it is dragging the storm zone along with it. Run your finger down a map of the United States, straight down the 100th line of longitude, and you are tracing one of the most important boundaries in American history. It cuts through the middle of the Dakotas, down through Nebraska and Kansas, across Oklahoma and into Texas. For more than a century, this line marked the Great Divide of the country. West of it, the land was dry. East of it, the land was wet. Explorers and scientists noticed it long ago. On the eastern side, rain fell reliably, forests grew, and farmers could plant without irrigation. On the western side, the land turned arid, the grass grew short, and survival demanded canals and wells. That invisible seam decided how the whole country was settled, farmed, and fed. It was the border between 2 Americas, one green, one brown. Here is the unsettling news. That ancient line is no longer holding still. In recent decades, this divide between the arid west and the humid east has been creeping eastward. The dry side is expanding. The wet side is being pushed back. Land that once sat comfortably in the green half of the country is drifting toward the brown half, growing drier year by year. This is a bigger, slower cousin of the dry line we met earlier. The dry line shifts day to day with the weather. This great continental divide shifts across decades with the climate itself. But they move for the same reason, and they move in the same direction. East. Why does a farming boundary matter for tornadoes? Because tornadoes are born exactly where dry air meets wet air. That is the whole recipe. When the master boundary between the country's dry half and wet half slides east, the collision zone slides east with it. The place where the 2 air masses fight and the storms ignite tracks along that moving seam. So picture 2 great walls drifting together across the map. The everyday dry line, the century-scale divide, both walking east, both dragging the birthplace of tornadoes toward the Mississippi Valley and the southeast. The storms are not choosing to move, they are being carried, riding boundaries that are themselves on a slow march across the continent. And when those boundaries reach their new resting places, the storms fire over ground that could not be more different from the plains. This is the hinge of the entire story. For 100 years, the recipe was cooked over open, empty grassland. Now the same recipe is being cooked over forests, hills, rivers, and towns. Same storms, radically different stage. That difference is everything. It is the whole reason a shift on a map becomes a threat to human life. Out west, the geography was forgiving. It gave people distance, daylight, and clear sight lines. It let a tornado spend its fury on empty fields. The new ground offers none of that mercy. It hides the storms, crowds the victims, and swallows the warnings. We have spent these chapters tracing why the storms are moving. The drought, the dome, the gulf, the jet stream, the drifting lines. Now the question turns from why to what happens when they arrive. What makes the plains a place a tornado could rage almost harmlessly, and the southeast a place the same tornado becomes a massacre? To answer that, we have to stand in both landscapes and see them through a tornado's eyes. Start with the plains, and the strange gift of being able to see your enemy coming from miles away. Stand in the middle of western Kansas and turn in a slow circle. What you see is almost nothing, and that nothing is a gift. Flat land stretches to the horizon in every direction. No hills, few trees, just grass and sky and a view that runs for 20 miles. Out here, when a tornado forms, you can watch it being born. You can see the funnel drop, track its path, and know minutes in advance whether it is coming for you. That single fact, the ability to see, has saved countless lives on the plains. A tornado on open grassland is a visible enemy. Farmers spot it from their porches. Drivers see it across the fields. Storm spotters radio its position to warning centres. Everyone gets a head start because the land hides nothing. The plains offered a second gift too: emptiness. The heart of Tornado Alley is some of the least crowded land in the country. Vast stretches of farm and ranch, with towns spaced far apart and long miles of nothing in between. When a tornado touches down out there, the odds are good that it rages across an empty field, tears up some crops, and dissipates without ever meeting a human being. Think about what that means. A violent tornado, one of the strongest storms nature can produce, can spin across the western plains and harm no one at all, simply because there was no one in the way. The same wind that would erase a neighbourhood instead scours bare dirt. Geography turned catastrophe into spectacle. There was a third gift, quieter than the others: timing. The classic plain season peaked in spring, and crucially tended to fire in the afternoon and early evening. Warm days build the instability the storms need, so the plains twisters often struck while the sun was still up and people were awake. Daylight and alertness are their own kind of shield. You cannot flee a danger you are sleeping through. Put those three gifts together: wide sight lines, empty land, daytime timing. The plains were, in a dark way, the safest place on Earth to have a tornado. The storms were monstrous, but the stage was forgiving. It gave people every advantage: distance to see, space to spare, light to act. This is the piece most people miss when they picture Tornado Alley. They imagine it as the most dangerous place in the country. In truth, for the people living there, the plains softened the blow at every turn. The famous tornado footage, the clean funnel crossing an open field with a camera rolling safely nearby, exists precisely because the land let humans keep their distance. Now hold that picture of mercy in your mind, because we are about to destroy it. Everything the plains gave, the new alley takes away. The sightlines vanish. The emptiness fills with people. The daytime shifts to darkness. Every single advantage flips into a disadvantage, and the same storm that would have crossed a harmless field now crosses a sleeping town it cannot even be seen approaching. The eastward shift is moving tornadoes onto the worst possible ground, a landscape that strips away every protection the plains once offered and replaces it with traps. The first trap is the one that turns a survivable storm into a mass killer. It comes down to the darkness, and in the new alley, far more tornadoes come after the sun goes down. A tornado at 2 in the afternoon and a tornado at 2 in the morning are two completely different monsters. Same wind, same fury, but one arrives while you're awake watching the sky ready to run. The other arrives while you're unconscious, tucked in bed, with your phone silenced on the nightstand. The second one is the killer. In the New Alley, far more tornadoes come after dark than on the plains. This is one of the defining features of the Southeast, and it is deadly by design. When the sun goes down, 3 protections disappear at once. You cannot see the storm coming, you may not hear the warning, and you have lost the daylight alertness that lets you make fast, clear decisions. Consider one grim statistic that captures the whole problem. In Tennessee, a state deep in the new tornado zone, nearly half of all tornadoes strike after dark. Read that again. Half. Flip a coin, and that is the odds that a Tennessee tornado comes in the night, when the population is asleep and defenseless. Why does the Southeast produce so many nighttime twisters, when the plains produce so few? Part of it is the season. As we saw, the eastern outbreaks lean into the cooler months, when days are short and darkness comes early. A storm that fires at 6 in the evening in December is already firing into the night. Part of it is the fast winter jet stream, carrying storms into the region during the overnight hours when systems are still cranking. But the deepest reason is simple and merciless. The atmosphere over the Southeast can stay unstable long after sunset. On the plains, storms often needed the sun's heat to build, so they weakened as evening cooled the ground. In the moist, warm air of the deep south, fed by that fevered Gulf, the fuel lingers into the night. The engine keeps running after dark, long after a plainstorm would have sputtered out. Now imagine the scene inside a house. It is past midnight. The family is asleep. A warning goes out, but the television is off. The radio is silent, and a phone alert is easy to sleep through, if the phone even makes a sound. The tornado is minutes away, and no one in the house knows. Outside, the funnel is invisible against the black sky, hidden further by rain and trees. By the time anyone hears the roar, there is no time left to reach shelter. That is not a rare nightmare. That is the ordinary way people die in Dixie Alley. The storm does not need to be enormous. It only needs to arrive while its victims are unconscious and blind. Compare that to the plains scenario. Afternoon, bright sky. A farmer sees the wall cloud from 10 miles off, calls his family into the cellar, and watches the tornado pass through binoculars. Same storm, utterly different ending. The only variable that changed was the light. This is why meteorologists lose sleep over the nighttime shift more than almost anything else. You can build stronger houses, you can improve forecasts, but you cannot easily wake a sleeping city, and you cannot make an invisible storm visible in the dark. Darkness is the great multiplier of death, and the New Alley delivers far more storms into it. Just how much deadlier is a tornado in the dark? Scientists put a number on it years ago, and the number is chilling enough to change how you think about every warning you sleep through. Scientists do not like to guess. They like to measure. So years ago, a team of researchers set out to answer a blunt question with hard data. If a tornado strikes at night instead of during the day, how much more likely is it to kill someone? They gathered decades of tornado records, sorted them by the hour they struck, and counted the dead. The answer came back sharp and unforgiving. Nighttime tornadoes are roughly 2.5 times more likely to kill people than daytime tornadoes. Sit with that multiplier. 2.5 times. Take the exact same tornado, the same width, the same wind, the same path, and simply move it from afternoon to the middle of the night, and its power to kill more than doubles. Nothing about the storm changed, only the darkness and the sleeping people inside it. That single finding reframes the entire eastward shift. We already know the storms are moving into a region where far more of them strike after dark. Now layer this number on top. Not only are more tornadoes coming at night in the New Alley, but each of those nighttime tornadoes is inherently more than twice as lethal. The two facts stack, and the danger compounds. Why does the dark multiply death so sharply? It comes down to the chain of survival, and darkness snaps almost every link. To live through a tornado, you must first learn it is coming. Then you must believe the warning. Then you must move to shelter in time. During the day, awake and alert, you can complete that chain in minutes. At night, every link is broken or delayed. You cannot learn of the storm if the alert does not wake you. A large share of people sleep straight through phone alerts and outdoor sirens, which were never designed to rouse a sleeping household. Sirens are meant to warn people already outside, not a family behind closed windows on a stormy night. Even if you wake, you cannot see to confirm the threat, so precious seconds vanish in confusion. Is it real? Is it close? By the time the answer becomes obvious, the roar is already at the door, and moving through a dark house, gathering children, finding the safe room, all of it takes longer when you are groggy and blind and terrified. There is a slow-motion tragedy hidden in the long record of tornadoes. Over the last century, the overall tornado death rate in America has fallen dramatically, thanks to radar, forecasting, and warnings. Fewer people die per storm than ever before. It is one of the quiet triumphs of modern science. But that triumph has a stubborn exception. The death rate for nighttime tornadoes has fallen much more slowly than for daytime ones. All our technology has struggled against the simple problem of the dark. We can see the storm on radar. We can issue the warning with time to spare. And still, again and again, the warning fails to reach a person asleep in a house they cannot defend. So the shift east is feeding tornadoes into the one condition our defences have never truly solved. The dark is the gap in our armour, and the New Alley aims storms straight at it. But darkness is only the first trap. Even a person wide awake in daylight can be blindsided in the southeast, because the very trees that make the region beautiful can hide a monster until it is on top of you. The South loves its trees, and for good reason. In a land of brutal summer heat, forests give shade, beauty, and cool relief. Oaks and pines line the roads, shroud the hills, and crowd right up to the edges of towns. It is one of the most beautiful landscapes in the country. It is also, for a tornado, the perfect hiding place. Remember the gift of the plains, that 20-mile view across open grass. The southeast erases it completely. Here the land rolls and folds into hills, and trees rise like walls in every direction. A person standing in their yard cannot see across a single field, let alone across the miles a tornado travels. The horizon is gone, swallowed by green. So when a tornado approaches through the southern woods, the people in its path often cannot see it at all. There is no clean funnel crossing an open plain. There is a wall of trees, and behind that wall, unseen, a monster grinding closer. The first sign might be the sound, a roar like a freight train, arriving only seconds before the wind itself. By then it is far too late to run. This is why survivors in the South so often say the same haunting words. It came out of nowhere. It did not come out of nowhere. It came out of the trees which hid it until the final moment. The forest does something worse than hide the storm. It arms it. On the open plains, a tornado picks up dirt, grass, and the occasional fence post. In the southern woods, a tornado tears through a canopy of full-grown timber, ripping trees from the earth and hurling them like spears. What was a shade tree in the morning becomes a battering ram by afternoon. The wind fills with heavy, jagged debris, and every piece of it is a weapon. Picture the difference. A plains tornado is a column of wind and dust. A Dixie Alley tornado is a column of wind packed with entire trees, roofs, and shattered timber. A churning cloud of solid objects moving at highway speed. Even a person in a sturdy house faces a bombardment of debris, driven straight through the walls, on top of the wind itself. The trees betray people one more time after the storm has passed. In the aftermath, the same forests that hid the tornado now block every road. Downed trees fall across the narrow, winding country roads of the rural South, and they fall by the thousands. A single tree across a lane can seal off an entire community. Rescue crews cannot get in. The injured cannot get out. Help that would take minutes on an open plain takes hours, or does not come at all. There is a bitter irony in all of this. The features that make the South livable, the trees, the shade, the rolling green hills, are the very features that make its tornadoes so lethal. The landscape that soothes in summer kills in a storm. And notice how this trap layers onto the last one. Darkness already blinds the region at night. Now add trees that blind it even in daylight. A person in the southeast can be robbed of sight two ways at once, by the night and by the forest, both hiding the same approaching death. Yet even a clear day and open ground would not fully save these storm's victims, because the southeast has one more way of hiding its tornadoes. Some of them wrap themselves in rain, becoming invisible even to a person staring straight at them. There is a kind of tornado that can stand a mile in front of you, in broad daylight, and remain completely invisible. It hides inside a curtain of its own falling rain, needing neither trees nor darkness to disappear. Meteorologists have a name for it, a rain-wrapped tornado, and in the humid southeast it is terrifyingly common. To understand how a storm can vanish inside its own rain, go back to the moisture. The air over the southeast is soaked with water hauled up from the warm Gulf. That extra humidity does something to the clouds. It drops their bases lower and packs them denser, and it produces torrential, blinding rain that wraps around the spinning core of the storm. On the plains, drier air often keeps the rain and the tornado separate. The funnel spins in clear air, sharp against the sky, easy to photograph and easy to track. That is the classic image everyone knows. In the southeast, the rain and the tornado occupy the same space. The funnel spins deep inside a wall of water so thick you cannot see through it. From the outside, it looks like nothing more than heavy rain. Inside that rain hides a killer. Imagine watching a storm approach. The sky is dark and pouring. It looks like an ordinary downpour, the kind you would drive through without a second thought. But somewhere in that grey wall, a tornado is churning toward you at highway speed, and you have no way to see it. You are staring directly at your own death, and seeing only rain. This is why rain-wrapped tornadoes are among the deadliest of all. They defeat the one defense that saves so many lives on the plains, the human eye. A storm spotter, a driver, a family on a porch, none of them can confirm what the radar is warning about because the tornado is cloaked. People hesitate. They wait for visual proof that never comes. And in that hesitation, the storm arrives. Sometimes the only hint that a tornado lurks inside the rain is a flash of light. As the funnel destroys power lines, transformers explode in bursts of blue and green, glowing through the downpour. Those eerie flashes, called power flashes, are occasionally the only sign that something is spinning inside the curtain. People have reported seeing strange lights in the rain, not realizing they were watching electrical infrastructure being torn apart by a tornado they could not see. Now stack all three blinding traps together, because in the southeast they often strike at once. It is night, so darkness hides the storm. The land is wooded, so trees hide the storm, and the tornado is wrapped in heavy rain, so even the open sky hides the storm. Three separate veils drawn over the same monster at the same moment. A person can be blind to an approaching tornado in three different ways simultaneously. This is the cruel genius of the New Alley. The plains gave people sight, and sight gave them a chance. The southeast takes sight away by every means available. Darkness, forest, and rain conspire so that the warning on the phone may be the only knowledge a family ever gets that death is minutes away. And that assumes the family even hears the warning and has somewhere safe to go when they do. But the homes of the region carry their own deadly weakness, one built right into the walls, because a huge share of the people in the storm's path live in houses that a tornado can destroy in a single breath. Not all houses are built to fight a tornado, and in the New Alley, an enormous number of them cannot fight at all. They are manufactured homes, sometimes called mobile homes, and they are one of the single greatest reasons the southeast buries so many of its people. The numbers are staggering, and they deserve to be spoken slowly. Nationwide data on tornado deaths shows that more than half of the people killed at home during tornadoes were inside manufactured homes. Over half. Yet those homes make up only a small slice of the housing in the region, somewhere around 1 in 10. A tenth of the houses account for a majority of the deaths. No other single factor comes close to that kind of imbalance. Why are these homes so deadly? It comes down to how they are built and how they are anchored. A traditional house is framed into a foundation, bolted and braced to hold against the wind. A manufactured home is built in a factory and set onto its site, often without the deep anchoring that ties a structure to the earth. When violent wind hits, these homes can be lifted, rolled, and torn apart. The very thing that makes them affordable, their light and portable construction, makes them fragile against a tornado. A tornado does not even need to be a giant to destroy one. On the plains, a weaker tornado crossing an empty field harms no one. In the southeast, that same weak tornado can flatten a manufactured home and kill everyone inside. The storm did not have to be strong. The house simply could not hold. Now combine this with everything we have already seen. The storm comes at night, so the family's asleep inside. It is hidden by trees and rain, so no one sees it coming. The warning may not wake them, and the walls around them offer almost no protection at all. 4 deadly factors, all present in the same small home at the same terrible moment. There is a geographic cruelty here too. Manufactured homes are common across the rural south, spread through exactly the countryside where the storms now roam. So the eastward shift is sending tornadoes towards some of the most vulnerable homes in the country, in the region where such homes are most concentrated. Picture two families, one on the plains in a braced house with a storm cellar, one in the south in a manufactured home with no shelter nearby. The same tornado passes over both. The first family climbs out of the cellar to survey damaged crops. The second family may not survive the night. The wind was identical, the walls were not. This is the hard truth that the beautiful footage of plains tornadoes never shows you. The danger of a tornado lives in what stands between that wind and a human body, as much as in the wind speed itself, and across much of the New Alley, what stands there is a home the storm can peel open like paper. The people inside those homes are not careless. They live where they can afford to live, in a region where the tornado threat used to feel like someone else's problem. Now the problem has moved to their doorstep, and their doorstep is dangerously thin. But housing is only one part of why the human toll is climbing. The deeper reason is simpler and larger. The storms are moving toward far, far more people than the plains ever held. The plains had space to spare. The southeast does not. This is the plainest and heaviest reason the eastward shift is so dangerous, and it needs no complicated science to grasp. Tornadoes are moving from a nearly empty part of the country into a crowded one. More people in the path means more people in the grave. Go back to that western Kansas field, where a tornado could rage for an hour and never touch a soul. Now travel east into the Mississippi Valley and the deep south, and the emptiness disappears. Towns cluster along the rivers and highways. Suburbs sprawl outward from cities. Country roads are dotted with homes, churches, schools, and trailer parks. The land is full of life, which means it is full of targets. When a tornado touches down in the rural plains, the most likely outcome is that it hits nothing but dirt. When a tornado touches down in the populated southeast, the odds flip. Now it is far more likely to cross a neighborhood, a town, a stretch of road lined with houses. The same storm that would have died unnoticed on the prairie instead carves a path straight through human lives. This is the multiplier that turns a modest shift in tornado numbers into a sharp rise in danger. Even if the total count of tornadoes barely changed, moving them from empty land to crowded land raises the human cost enormously. It comes down to how many people stand where the tornadoes land, more than how many tornadoes there are. And the crowd is growing. The southeast has been one of the faster growing regions of the country, drawing new residents into cities and spreading suburbs into what used to be farm and forest. Every new subdivision, every new town on the edge of the trees, places more people inside the storm zone. The population is expanding into the exact ground the tornadoes are moving toward. Two trends racing at each other from opposite directions, destined to collide. Think of it like a game of chance where the board keeps changing. On the plains, most of the squares were empty, so most spins landed on nothing. In the southeast, most of the squares are occupied, so most spins land on someone. The dice are the same. The board is far more crowded. Every roll now carries a human cost the plains rarely paid. There is a quiet injustice in this too. Many of the people now in harm's way never thought of themselves as living in tornado country. They grew up believing tornadoes were a Great Plains story, something that happened to other people in flatter states. Now that place has come to them, and the old assumption of safety leaves people slower to prepare and slower to react. So the storms are not just moving toward more bodies. They are moving toward more bodies that are less ready, in a region that historically built its habits and its shelters for a threat it thought belonged elsewhere. This is the true heart of the danger. Wind is wind. What makes the eastward shift a rising catastrophe is the collision of that wind with a dense, growing, underprepared population in homes that cannot hold, under cover of trees and darkness and rain. And there is one more disadvantage buried literally beneath these homes, in the very ground they stand on. Because unlike the plains, much of the South cannot easily dig the one thing that has saved more tornado victims than anything else. A hole to hide in. The single safest place to be during a tornado is underground. A basement or a storm cellar puts solid earth between you and the wind, and earth does not fly away. For generations on the plains, families climbed down into cellars, pulled the door shut, and listened to the storm pass harmlessly overhead. That hole in the ground has saved more lives than almost any warning system ever built. Much of the southeast cannot dig that hole. The reason is hidden in the ground itself. Across large parts of the south, the water table sits high, meaning water lurks just below the surface. Dig down a few feet and you hit damp earth, then water. A basement in that kind of ground would flood, crack, and fill with moisture. So builders across the region simply stopped digging them. Instead, they build homes on concrete slabs, poured flat on the surface with nothing below. A slab home is fine on an ordinary day, but when a tornado comes, its residents have no easy way down. There is no cellar to descend into, no earth to hide behind. The best they can do is find an interior room, a closet or a bathroom, and hope the walls hold. Against a strong tornado, hope is often all they have. Stack this against the plains once more. A plains family hears the warning and vanishes underground, safe beneath the soil. A southern family hears the same warning and has nowhere to go but a hallway, still surrounded by the same fragile walls the tornado is trying to tear down. The warning reached both families equally. Only one had a place to use it. For those in manufactured homes, the problem is even sharper. These homes almost never have any shelter beneath them, and the guidance in a tornado is blunt and frightening. Get out. Leave the home entirely and reach a sturdy building or an underground shelter. But if it is the middle of a rainy night, the tornado is wrapped in darkness, and the nearest solid shelter is miles down a road blocked by fallen trees, that advice can be impossible to follow. Where do you run when there is nowhere to run to and no time to get there? Some communities have built public storm shelters, and some families have installed reinforced safe rooms, small boxes of steel and concrete strong enough to survive a direct hit. These save lives, but they cost money, they require planning, and they are far from universal across a region that only recently began to think of itself as tornado country. Vast numbers of homes still have no true shelter of any kind. So here is the full weight of the trap. The storms are moving into the south. They come at night, hidden by trees and rain. They strike homes that cannot hold. They cross a landscape packed with people, and when those people try to take shelter, many discover there is no shelter to take. The one defense that saved the plains, the hole in the ground, is missing from much of the ground the storms now roam. It is a stack of disadvantages so complete it almost feels designed. Every protection the plains offered has been stripped away, replaced by a matching danger. And the last of those dangers is time itself. Because even a family with a plan and a shelter can be defeated if the storm gives them no time to reach it. And in the New Alley, the clock runs cruelly short. Survival during a tornado comes down to a race against a clock, and in the New Alley, that clock runs cruelly fast. Even a family that hears the warning, believes it, and knows exactly where to shelter, can lose the race if the storm moves too fast. In the southeast, again and again, it does. Remember the diving jet stream, that fast river of air that plunges south into the region during the cooler months. It does more than deliver storms. It shoves them across the ground at ferocious speed. A tornado on the plains might amble along at a jogging pace. A tornado riding a strong winter jet in the south can barrel forward at highway speeds. The faster it moves, the less warning time anyone gets. Now think about what that speed does to the precious minutes between a warning and impact. Forecasters may issue a warning with solid lead time, but if the storm is racing forward, those minutes evaporate. A family that would have had a comfortable window to reach shelter instead has seconds. And seconds are not enough to wake a household, gather children, and cross a dark, storm-lashed yard to a distant safe room. The landscape steals time in its own way too. On the open plains, roads run straight and clear, and a person could, in theory, drive out of a tornado's path. In the rural south, the roads are narrow, winding, and few. They twist through hills and forests, and they offer no straight escape. Worse, as the storm approaches, it begins dropping trees across those very roads. An escape route that was open one moment is sealed the next, one falling tree at a time. Picture trying to flee down a country lane at night, in driving rain, with a tornado you cannot see closing in behind you, only to round a bend and find the road blocked by a fallen oak. There is no time to turn around. The trees that hid the storm now trap you in its path. This is why a single planned escape route is so dangerous in the south. Any one road is only one tree away from being closed. The very act of trying to drive to safety can leave a family stranded in a vehicle, one of the worst places to be in a tornado. So the clock runs short from every direction at once. The storm moves faster because of the jet stream. The warning window shrinks because the storm is racing. The escape routes are few, winding and prone to blocking, and all of this often unfolds in the dark when every action takes longer and every decision comes harder. Stack the full trap one final time so its shape is unmistakable. Tornadoes are moving into a crowded region. They come at night, hidden by trees and rain. They strike fragile homes. Many residents have no shelter to reach, and even those who do may not have time to reach it before the storm is upon them. Every layer compounds the last. Every advantage the plains offered has become a disadvantage in the south. We have built the full picture of why the New Alley is so deadly. Now it is time to see that picture come alive, in real events, on real dates, in towns with real names. Because the eastward shift is not a forecast. It has already happened, and it has already killed. The proof begins with a single spring day the entire South will never forget. In late April of 2011, the atmosphere over the American South loaded itself into a configuration meteorologists had feared but rarely seen. Every ingredient for catastrophe lined up at once. Deep Gulf moisture flooded north. A powerful storm system swept in from the west. The air grew violently unstable, and the winds aloft raced in the perfect pattern to set the sky spinning. Forecasters looked at their screens and felt dread. What followed became the largest tornado outbreak ever recorded in the United States. Over several days, from the 25th to the 28th of April, the country was raked by an unimaginable number of tornadoes. When the surveys were finished, the count reached 362 confirmed tornadoes across 21 states from Texas all the way to New York. But the numbers alone cannot hold the horror of it. The outbreak killed 321 people. Most of them died on a single day, the 27th of April, when the sky over the Deep South seemed to come apart all at once. Whole communities were erased in an afternoon and evening of relentless overlapping tornadoes. The damage climbed toward $12 billion, ranking it among the costliest natural disasters the nation had ever endured. Now hold this against everything we have learned. Where did this record outbreak strike hardest? The Deep South, the New Alley, the very region the storms have been drifting toward. This was not a plains event. This was Dixie Alley at its most monstrous. The deadliest tornado outbreak in modern memory unfolding across exactly the crowded, wooded, vulnerable ground we have been describing. One meteorologist watching it happen said he had never in more than 30 years of forecasting seen so many violent tornadoes showing up on radar at the same moment. That is what made this outbreak so uniquely terrible. Dozens of strong and violent tornadoes fired across the region hour after hour, overwhelming every warning system and every rescue crew at once. The clustering we spoke of earlier, tornadoes arriving in a single savage burst rather than spread across the calendar, reached its most extreme and deadly form. Imagine being a forecaster that day, watching your radar bloom with signature after signature of rotating storms, each one a potential killer, all in motion at the same time. There were more violent tornadoes on the screen at once than the veterans had seen in their entire careers, and there was nothing to do but warn and watch and pray. The warnings reached people in time. For the South, the day became a permanent scar. Families lost everything, towns were flattened to their foundations, and the event stands as a grim monument to what the New Alley can produce when every ingredient aligns. It was proof, written in tragedy, that the deadliest tornado ground in the country had shifted decisively into the southeast. The outbreak also carried a warning about the future. If this is what the region can do now, what happens as the warming Gulf hands it even more fuel, as the storms drift even further into these crowded lands as more people move into the path? The record set in 2011 may not stand forever. To understand why this outbreak hit so hard, we have to step inside the storms themselves, into the specific tornadoes that carved the deepest wounds. Because among the hundreds that day were a rare few of the very strongest kind nature can produce, and one of them was heading straight for a city. Tornadoes are ranked on a scale of intensity, and at the very top sit the rarest and most violent storms of all, with winds strong enough to sweep sturdy homes clean off their foundations and strip the bark from trees. In a typical year, the country might see only a handful that reach that highest tier, and some years none at all. They are the crown monsters of the atmosphere. On the worst day of the 2011 outbreak, The sky produced 4 of them. Alongside those 4 Crown Tier tornadoes came 11 more in the next tier down, and 21 in the tier below that. This was an entire family of giants, a concentration of extreme tornadoes so dense it defied everything forecasters thought possible in a single event, and the great majority of them tore through the Deep South, through Alabama, Mississippi, and their neighbors. Alabama bore the deepest wound. The state lost hundreds of its people in a matter of hours, more than any other. Among the storms that ravaged it was a massive tornado that ground its way across the western part of the state and straight into populated areas, including the city of Tuscaloosa, and onward toward Birmingham. This was a tornado moving directly through cities full of people, homes and businesses, far from any empty prairie. Picture that scene through the lens of everything we have learned. A tornado near the top of the intensity scale, wide and violent, crossing a densely populated urban corridor of neighborhoods and college streets and shopping districts. Every fear we have described about the crowded southeast made real at once. The storm did not have to search for victims. They were everywhere in its path. The destruction was total along the worst of the track. Buildings were reduced to bare slabs. Trees were shredded into splinters, then hurled through whatever remained standing. Entire neighborhoods that had stood for generations were unrecognizable within minutes, and because so many of the day's tornadoes struck populated ground, the human toll climbed into a nightmare few living Americans had ever witnessed. To find an outbreak that killed on this scale, you have to reach back decades to another infamous super outbreak from the 1970s. For nearly 40 years, nothing had matched that older disaster. Then 2011 arrived and rivaled it. A grim reminder that these historic catastrophes are not safely locked in the past. They can still happen, and they can happen in the very region the storms are now favouring. What makes the Crown Tier tornadoes so uniquely deadly is that no ordinary home can survive them. The advice we cling to, find an interior room and ride it out, works against many tornadoes. Against the strongest, an above-ground room is not enough. Only true underground shelter or a reinforced safe room offers real protection, and across much of the South, that shelter is exactly what so many homes lack. So the 2011 outbreak was a collision of the worst possible storm with the worst possible ground. The rarest, strongest tornadoes, striking the most crowded, least sheltered part of tornado country. It stands as the clearest evidence we have of what the eastward shift means when it reaches its full and terrible potential. And yet, for all its horror, that outbreak came in the spring, the season people still half expected. The next great warning would come at a time no one was ready for on a December night, when the very idea of a tornado should have been impossible. December is supposed to be safe. By the 10th of the month, most of the country has put away any thought of tornadoes. The air is cold, the ground is bare. Families are thinking about the holidays, not the sky. That is exactly what made the night of December 10th, 2021, so uniquely deadly. The storm came at the one time of year no one was watching for it. The setup was unnatural for the season. Across the Mid-South, the day had been wrongly warm, with temperatures near 80 degrees in the middle of December. That warmth flowed north from a Gulf of Mexico running about 5 degrees hotter than normal, pumping summer-like moisture into a winter sky. On top of that humid air came a powerful storm system from the west and a fierce field of winds aloft to set it spinning. Every ingredient for a violent outbreak had assembled in December in defiance of the calendar. Forecasters saw it coming and raised the alarm days ahead, steadily escalating their warnings as the threat sharpened. But knowing a storm is coming and stopping it from killing are two very different things, especially when it strikes at night in a region full of vulnerable homes. When darkness fell, the sky delivered. Storms erupted across the Mid-South and quickly organized into rotating supercells. Over the course of that night and into the next morning, dozens of tornadoes tore across a string of states, from Arkansas and Missouri through Illinois and Tennessee and into Kentucky. In the end, more than 70 tornadoes were confirmed, and the death toll climbed to nearly 90 people, with damages reaching into the billions. Now recognize what you're looking at. This outbreak checked nearly every box we have described about the New Alley, all at once. It struck in the cold season, when tornadoes were not supposed to come. It struck at night, when families were asleep. It fed on a warm Gulf that should have cooled for winter. It raked the crowded, wooded Mid-South, tearing through the exact region the storms have been drifting toward. It was the eastward shift made flesh on a December night in the worst possible conditions. The late timing was itself a weapon. Communities that had braced for tornadoes in spring were caught completely off guard by a December assault. Shelters were not staffed for it. Mines were not ready for it. The very calendar that people trusted to keep them safe had betrayed them. A warm Gulf and a diving jet stream do not check the date before they build a monster. Think of how surreal it must have felt. Christmas lights on the houses, cold air expected any day, and instead a warm, heavy wind, a darkening sky, and then the roar of tornadoes ripping through town after town in the dead of night. It was a season out of joint, a winter behaving like a violent spring. For meteorologists, the December outbreak was more than a tragedy. It was a signpost. It showed, with brutal clarity, that the rules had changed, that a warming Gulf could keep the tornado machine running into the depths of winter, that the deadliest storms could now arrive in months families had always considered safe, and within that outbreak was a single storm so vast and so long-lived that it became a legend in its own right. One supercell, one tornado, that refused to lift for mile after mile after mile, carving a scar across multiple states and into the heart of a Kentucky town. Most tornadoes live and die in minutes. They touch down, rage for a few miles, and dissolve back into the storm that made them. What happened on that December night broke that pattern entirely. A single supercell thunderstorm formed over Arkansas and then refused to die, holding together for hour after hour as it marched northeast across the map. Meteorologists tracked that one storm across a distance of more than 250 miles. From that long-lived supercell dropped a tornado that became infamous. It stayed on the ground for an astonishing stretch, grinding across the landscape for roughly 165 miles through Kentucky, remaining a tornado for close to 3 hours. To picture that, imagine a tornado forming and then staying on the ground for the length of a long highway drive, never lifting, chewing through everything in its path the entire way. Storms like that are almost unheard of. This was one of the strongest tornadoes of the outbreak, with winds estimated around 190 miles an hour. And it was aimed, through the dark, straight at communities that never had a chance to see it coming. In the town of Mayfield, Kentucky, the tornado struck a candle factory where workers were on the job late into the night. The building collapsed under the force of the wind, trapping people inside and turning a place of work into a scene of disaster. It was the kind of tragedy that captures a nation's attention because it made the abstract danger horribly concrete. Ordinary people, at their jobs, in the dark, crushed by a storm they could not have outrun. The same storm system tore through other communities with the same merciless force. It flattened much of Dawson Springs, another Kentucky town. It caused catastrophic damage in Bowling Green. Across the wider outbreak, a warehouse collapsed in Illinois, and a nursing home was struck in Arkansas, each collapse adding to the toll. Community after community in the middle of the night met a storm they could barely detect until it was upon them. Every element of the New Alley's cruelty was on display in this single tornado. It came at night, so its victims were asleep or working blind. It was hidden by darkness and rain, so few could see it approach. It moved fast and stayed on the ground impossibly long, so there was no outrunning it. It struck a crowded region full of homes and workplaces, and it hit with winds strong enough that no ordinary building could stand against them. The scale of this one storm is hard to hold in the mind. One supercell, alive for 250 miles. One tornado, on the ground for 165 miles and nearly 3 hours. Dozens of lives lost along that single path alone. It is the kind of event that once seemed to belong only to history, and yet it happened, in December, in the New Alley in our own time. For the survivors and the families of the lost, the beast that would not lift became the defining horror of their lives. For scientists, it became a stark example of what these storms are now capable of, in the wrong season, over the wrong ground. And it forced an uncomfortable question to the surface. If tornadoes like this can now come in December, then the old idea of a tornado season, a safe time and a dangerous time, may be finished. What does it mean for millions of people when the threat no longer keeps to a calendar at all? A tornado outbreak in spring is a tragedy. A tornado outbreak in December is a warning about the future. The difference matters, and understanding it is the key to grasping where all of this is heading. Because the storms arriving out of season are telling us something the storms arriving on schedule never could. For most of history, winter was the tornado's off-season across the country. The Gulf cooled, the fuel ran low, the atmosphere over the south lost the heat and moisture it needed to build violent storms. Families could relax when the leaves fell, confident the danger had gone dormant until spring. That seasonal rhythm was woven into the culture of every tornado-prone town. The December outbreaks are breaking that rhythm, and they are breaking it for a specific physical reason. A warming Gulf does not cool down the way it used to. It holds its heat later into the year, keeping the fuel supply alive through months that were once safe. When a strong winter storm system and a diving jet stream arrive over that unnaturally warm water, they find the ingredients for tornadoes still sitting there, ready. The off-season is shrinking. This is why an out-of-season outbreak is so much more than a single disaster. It is evidence that the underlying conditions have shifted. A spring tornado fits the old pattern and tells us little that is new. A December tornado, born of a Gulf too warm to rest, is a direct sign that the machine is running longer and harder than it used to. It is the future showing its face early. And the danger of the off-season goes beyond the physics, straight into human behaviour. Communities prepare for what they expect. They hold drills in spring. They watch the sky in April and May. When the calendar turns to late autumn and winter, that vigilance fades, because for generations there was no reason to keep it. So a winter outbreak strikes people who are mentally, culturally and practically unprepared. The shelters are quieter. The warnings feel less believable. The whole region has its guard down. Picture a town that has always feared spring storms. Every family knows the drill for April. Then, one warm December night, the sirens sound, and half the town cannot quite believe it. Tornadoes now? In December? That disbelief is deadly. It slows the response, delays the sheltering, and costs the minutes that decide who lives. The unfamiliarity of the season becomes a weapon in the storm's hands, so the eastward shift and the seasonal shift work together, reinforcing each other. The storms are moving into more crowded, more vulnerable ground, and they are arriving at times when that ground is least ready. It is a double blow. New places, new seasons, both catching people off guard. The December outbreaks, then, are a message from the atmosphere, written in the worst possible ink. They say that the boundaries we relied on, the safe regions and the safe seasons, are dissolving together. They say that the warming that deepens the western drought and heats the Gulf is already reaching into the calendar and rewriting when death can come, close and concrete. If you want to know whether this is truly a trend and not a run of terrible luck, you do not have to look only to the past. The signs keep arriving season after season in the present. And one recent year offered a fresh and unmistakable warning, as an entire state found itself buried under storm after storm. Sometimes a single state becomes a window into the whole shift, and in a recent spring that state was Arkansas. What happened there offered a vivid, real-time picture of the new alley in action, and it left little doubt that the trend we have been tracing is still gathering force. Consider one striking comparison. In the 30 days after a mid-March outbreak, Arkansas was hammered with tornado warnings, at a rate that dwarfed the old heart of Tornado Alley. During that stretch, the state received around 144 tornado warnings. Texas, the classic plains giant, received only about 39 over the same period. Let that contrast sink in. Arkansas, in the new eastern zone, drew nearly 4 times as many warnings as Texas, the state most people still picture when they think of tornadoes. And Arkansas was not alone. Over that same span, Mississippi also saw around 144 warnings, and Tennessee well over 100. The Deep South and Mid-South lit up with warning after warning, while the traditional plains stayed comparatively quiet. This is precisely the pattern the data predicted, playing out live across the region. The storms were not just frequent, they were strong. Survey teams confirmed a large number of tornadoes touching down in Arkansas in a single season, well above what the state typically sees, and among them were tornadoes near the top of the intensity scale, the rare and violent kind. 2 of these powerful tornadoes struck the state on a single March day, in separate counties, a level of violence Arkansas had not seen in over a decade. To find the previous time such a strong tornado had hit the state, you had to reach back years to an earlier disaster that had carved a long path of destruction and killed more than a dozen people. The return of that kind of intensity after so long was itself a warning. The strongest storms were coming back and coming to the New Alley. Notice how this recent season ties every thread together. The warnings clustered in the east, not the plains, matching the geographic shift. The storms were violent, matching the trend toward bigger, meaner outbreaks, and they struck a Dixie Alley state directly, in the crowded, vulnerable region we have spent this whole story describing. This was not history. This was now, unfolding in real time, confirming that the pattern is alive and active. For the people of Arkansas and its neighbors, that spring was exhausting and terrifying. Warning after warning, night after night of watching the sky. Communities repeatedly forced into shelter, repeatedly bracing for the worst. It is one thing to read about a statistical shift on a map. It is another to live inside it, to have the sirens sound again and again across a single season. And this is the crucial point about the eastward shift. It is a present reality, adding fresh evidence with every passing year. The scientists who first noticed the drift said the trend was ongoing, that new proof arrived each season. Seasons like this one are exactly what they meant. So the storms keep coming into the crowded east, in growing numbers and growing strength. But tornadoes, for all their terror, are not even the whole story of what these storms bring. Riding alongside them is a quieter menace, one that rarely makes the headlines yet does even more damage across an even wider area. A menace that falls from the same violent skies. Tornadoes get all the attention, and it is easy to see why. There is nothing more visually shocking than a funnel tearing a house to pieces, but the scientist who first mapped the eastward shift has spent years pointing at a different threat, one that steals fewer headlines yet causes far more damage across the country. Hail. The same violent storms that spawn tornadoes also hurl ice from the sky, and not the gentle kind. Inside a powerful supercell, updrafts so strong they can suspend a chunk of ice in midair keep lifting water droplets high into the freezing upper reaches of the storm. There the droplets freeze, gather more water, and freeze again, growing layer by layer like a pearl until they are too heavy for even the mighty updraft to hold. Then they fall. By the time they hit the ground, these hailstones can be the size of golf balls, or baseballs, or larger. Ice that big, falling from miles up, strikes with shocking force, and crucially, large hail is a sign of an especially strong storm, the same strength that breeds violent tornadoes. Where you find giant hail, you often find the most dangerous storms of all. Here is why the researcher who tracks the shift keeps raising the alarm about hail. A tornado, for all its power, carves a relatively narrow path. It might be hundreds of yards wide and many miles long, but it touches only a thin ribbon of ground. Hail is different. A single hailstorm can pummel an area many miles across, all at once, battering everything beneath it. The tornado writes a line, the hail paints a whole region. Think about what that broad reach means for damage. Across that wide area, hail smashes roofs, shatters windshields, dents cars, and shreds crops in the field. A farmer's entire harvest can be destroyed in minutes. A whole town's worth of roofs and vehicles can be damaged in a single storm. Because it strikes such a large area, hail quietly racks up enormous costs, often exceeding the toll of the tornadoes that grab all the attention. So the eastward shift is moving these giant hail-producing storms toward more people as well, threatening homes, cars, and the farms that feed the region. It is a second front in the same war, and one that hits the wallet as hard as the tornado hits the home. The scientist studying this has taken his work into the field, chasing hailstorms directly to understand how and where the biggest stones form. It is dangerous, painstaking work, standing near the edge of monstrous storms to gather data on the ice they throw. But it reflects a serious conviction that hail is a rising and underappreciated danger, especially as these storms drift toward the crowded, growing southeast and mid-south. The lesson here reshapes how we should think about the whole threat. When these storms move east, they bring a whole package of hazards together. Violent wind, deadly tornadoes, often at night, hidden and fast, and giant hail spread across wide areas, wrecking property on a massive scale. The eastward shift multiplies many dangers at once. Yet even as the dangers multiply, something hopeful has been happening in the background for decades. Our ability to see these storms coming has improved dramatically. Radar, satellites, and forecasting have grown astonishingly good, which raises a puzzle at the heart of this whole story. If our warnings are so much better, why are these storms still so deadly? Here is a puzzle that sits at the center of the whole tornado story. Over the last 100 years, our ability to detect and warn about tornadoes has improved beyond anything the early forecasters could have dreamed. And yet, in the New Alley, people keep dying. How can both of these things be true at once? Start with the good news, because it is genuinely remarkable. A century ago, a tornado could strike a town with almost no warning at all. People simply looked up and ran. Since then, radar has been invented and refined until it can peer inside a storm and spot the telltale signature of rotation. Satellites watch the storms from above. Computer models forecast dangerous conditions days ahead. Warnings now reach phones, televisions, and radios across an entire region in an instant. The result has been a dramatic, life-saving decline in the tornado death rate over the decades. Fewer people die per storm than ever before. This is one of the great quiet victories of modern science. But that victory has an exception that refuses to yield, and it is the exact exception the New Alley exploits. While the overall death rate fell sharply, the death rate for nighttime tornadoes fell much more slowly. All our brilliant technology runs into a stubborn human wall. A warning is only useful if it reaches a person who is awake to receive it, alert enough to believe it, and able to reach shelter in time. In the dark, in a fragile home, in a region caught off guard, that chain keeps breaking no matter how good the radar becomes. This is the paradox. Our warnings have never been better, but the storms have moved into conditions that blunt those warnings. Better forecasting cannot wake a sleeping household. Sharper radar cannot make an invisible rain-wrapped tornado visible to a person on their porch. A perfect warning issued 20 minutes ahead means nothing if the family is asleep, or does not believe it, or has nowhere safe to go, or cannot get there before a fast storm arrives. So the eastward shift has, in a sense, outrun our progress. We got better at seeing the storms just as the storms moved toward the people hardest to protect. The technology advanced, but it advanced into a region and a set of conditions where technology alone cannot close the gap. The last mile of warning, the distance between a message on a screen and a person safe in shelter, remains the deadliest mile, and the New Alley is full of it. There is a hard lesson buried here. We often assume that better information automatically means more safety. But information is only the first step. It must be received, believed, and acted upon, and each of those steps can fail. In the crowded, wooded, slab-built, mobile home-dotted southeast, striking at night and out of season, the failures pile up exactly where the warnings are needed most. This is why experts insist that solving the tornado problem is about people as much as science. It is about waking the sleeping, convincing the doubtful, sheltering the exposed, and reaching the trapped. The atmosphere has handed us a puzzle that radar alone cannot solve, and there is one more twist that makes the human side even harder, a cruel trap hidden inside the warnings themselves. Because when warnings come too often, and too many of them turn out to be false, people stop listening. And a population that has stopped listening is a population in terrible danger. There is an old story about a boy who cried wolf so many times that when the real wolf finally came, no one believed him. That story is one of the deepest problems in tornado safety, and the New Alley makes it worse. To keep people safe, forecasters issue warnings whenever a storm looks capable of producing a tornado. This is the right thing to do because the cost of missing a real tornado is measured in lives. But storms are unpredictable, and many that look dangerous never actually drop a tornado to the ground. So a large share of tornado warnings, out of caution, turn out to be false alarms. The threat was real enough to warn about, but the tornado never came. Now think about what happens to a person who lives through this again and again. The sirens sound. They take shelter. Nothing happens. A week later the sirens sound again. They shelter again. Again, nothing. Season after season, warning after warning, the storm that was promised fails to arrive. Slowly, quietly, a dangerous thought takes root. Why bother? It never actually hits. That erosion of trust is deadly, because eventually the real one does come, and when it does, The person who has stopped believing the warnings may not shelter at all. They shrug off the siren as one more false alarm, stay where they are, and are caught in the open when the tornado that was real tears through. The warning worked perfectly. The human being had simply stopped listening. The new alley pours fuel on this fire in several ways. Remember that the storms here are moving into a region with 2 long tornado seasons and frequent outbreaks, so people face more warnings than ever. Remember the clustering, where a single active day can trigger a storm of alerts across a whole region. And remember that many of these storms are hidden, so a person who takes shelter often cannot even see whether the danger was real, leaving them with only the memory of yet another interruption that seemed to come to nothing. Layer on the out-of-season strikes. When a warning sounds in December, in a region that thinks of tornadoes as a spring problem, disbelief runs even deeper. It feels wrong, almost absurd, and that feeling makes people slower to act, or unwilling to act at all. The very unfamiliarity that makes winter storms so deadly also makes their warnings easier to dismiss. So forecasters are trapped between 2 terrible risks. Warn too little, and a real tornado catches people with no notice. Warn too much, and people stop trusting the warnings, so the real tornado catches them anyway. Threading that needle is one of the hardest challenges in all of weather safety, and there is no perfect answer. The way through is smarter, clearer, and more trusted warnings, paired with a public that understands why the warnings sometimes miss and takes them seriously anyway. It is a challenge of human psychology as much as atmospheric science. A warning that is not believed is no warning at all. All of this raises the biggest question of all, the one that hangs over the entire story. We have seen the storms move east, into more people, over deadlier ground, in more seasons. But is this the peak, or just the beginning? What do the scientists actually expect as the world keeps warming? The answer is more uncertain and more unsettling than you might think. Everyone wants a simple answer to one question. As the planet keeps warming, will there be more tornadoes or fewer? The honest reply is that tornadoes are one of the trickiest pieces of the entire climate puzzle, and the science here demands humility. But the pieces we do understand paint a picture worth taking seriously. Return to the recipe for a tornado. It needs 2 main ingredients working together. First, an unstable atmosphere, the warm, moist, buoyant air that fuels towering thunderstorms. Second, wind shear, the changing winds with height that set the storm spinning. A tornado needs both. Take away either one and you get no tornado. Here is where warming complicates everything, because it pushes those 2 ingredients in opposite directions. A warmer world with more heat and more moisture in the air tends to produce more of the first ingredient. More instability, more days when the atmosphere is primed to build powerful thunderstorms, especially across the eastern United States. On that count, warming loads the dice toward more storm potential. But the second ingredient may go the other way. Wind shear depends in part on the temperature difference between the warm tropics and the cold poles. As the world warms, the poles are heating faster than the tropics, which can shrink that temperature difference, and in turn, weaken the wind shear. Less shear means fewer chances for a storm to start spinning, so warming may quietly remove some of the very spin that tornadoes require. This is the great uncertainty at the heart of tornado science. One ingredient rising, the other possibly falling, more fuel, but perhaps less spin. Because these 2 effects fight each other, scientists cannot yet say with confidence whether the total number of tornadoes will climb or fall in a warmer world. Anyone who claims to know for certain is overstating what the science can support. But notice something crucial. The uncertainty is mostly about the total count. It is not about the shift we have already measured. The eastward drift, the movement toward the crowded southeast, the lengthening of the season, these are trends we can already see in the record, happening now, whatever the future total turns out to be. Even if the number of tornadoes held perfectly steady, moving them toward more people, in more seasons, over deadlier ground, would still raise the human toll. The where and the when may matter more than the how many. There is also the clustering to consider. Even without more tornadoes overall, a shift toward fewer but bigger outbreaks concentrates the danger, overwhelming warning systems and rescue crews on the worst days. A world with the same tornado count, but packed into more violent single-day eruptions, is a more dangerous world, not a safer one. So the responsible summary is this. We do not know for sure whether a warming climate will bring more tornadoes or fewer. We do have real evidence that the tornado threat is relocating and reshaping itself in ways that put more people at risk. The fog around the total count should not blind us to the trends we can already measure. Uncertainty about the future is not the same as safety in the present. That careful, honest picture, full of both real evidence and genuine unknowns, is exactly what makes this such a contested and fascinating scientific frontier. Because behind the headlines, scientists are still arguing, vigorously and in good faith, about how much of this is climate change and how much is simply the atmosphere's endless roll of the dice. Behind every clean headline about tornadoes moving east lies a messy, ongoing, and genuinely healthy scientific argument. Scientists agree that the shift is real. What they debate, fiercely and honestly, is exactly why it is happening and how much of it we can pin on a warming world. That debate is worth understanding because it separates careful thinking from easy answers. On one side sits the strong evidence for the shift itself. The eastward drift shows up in the long records. The decline in the plains and the rise in the southeast are measurable. The physical drivers we have explored, the western drought, the warming Gulf, the diving jet stream, the moving boundaries, all point in the same direction and all fit together sensibly. This is a robust finding. Few serious scientists dispute that the centre of tornado activity has been leaning southeast. But when it comes to the deeper cause, the picture grows cloudier, and good scientists say so plainly. Is the shift primarily driven by human-caused climate change? Or is it partly the result of natural, decades-long swings in the climate system that would have happened anyway? The atmosphere has always had long rhythms, patterns of drought and moisture that ebb and flow over many years. Untangling how much of the tornado shift comes from those natural rhythms and how much from a warming world is genuinely difficult. Some researchers point to changes in soil moisture across the plains. Others emphasize shifts in the jet stream or in pressure patterns over the ocean. These are not wild disagreements. They are the careful hashing out of a complex system, with different experts weighting different pieces of the puzzle. Science advances through exactly this kind of respectful argument. There is even debate about the framing itself. Some argue the southeast was always a major tornado region, distinct from the plains, and that we are partly just paying more attention to a danger that was there all along. Others counter that the measured increase east of the Mississippi is real and cannot be explained by attention alone, and there is humility about the size of the trend. Some experts stress that the shift, while real, has been gradual and subtle, a lean rather than a lurch. Tornadoes have not abandoned the plains, and they did not suddenly appear in the south. The change is a slow tilting of the odds, measured across decades, not an overnight transformation. Overstating it would be as much a mistake as ignoring it. This is what real science looks like. Not a single confident voice declaring the final answer, but a community of careful people, examining the same evidence, agreeing on what is solid, and arguing productively about what remains uncertain. The shift is well established. The precise causes and the exact future are still being worked out in journals and conferences and field studies season after season. For the rest of us, the takeaway is simple clarity about what we know. We know the storms are leaning east. We know the eastern ground is deadlier. We know the season is stretching. Those facts stand regardless of how the deeper debate resolves. The scientist can keep arguing about the ultimate why. Meanwhile, the risk on the ground is already here. And that brings us to the most important question of all, the one that turns this from a scientific curiosity into a matter of life and death. Who, exactly, is now living inside the path of these storms? The answer is a number large enough to take your breath away. We have traced the storms across the map, through the seasons, and into the science. Now we arrive at the reason all of it matters, the people. Because the eastward shift is moving tornadoes toward tens of millions of human beings, most of whom do not yet think of themselves as living in tornado country. Add up the core of the New Alley, and the scale becomes staggering. Mississippi, Alabama, Arkansas, Louisiana, Tennessee, and the reaching edges into Georgia, Kentucky, Missouri, and the Carolinas. This is a vast, populous region, home to a huge share of the American population, dense with cities, towns, suburbs, and rural communities. When the storms move here, they move into the middle of a crowd, and this crowd, as we have seen, carries every disadvantage stacked against it. Many live in homes that cannot withstand a strong tornado. Many have no basement or shelter to reach. Many will face the storms at night, hidden by trees and rain, in seasons they never learned to fear. The very features of the region, its forests, its housing, its geography, its growth, combine to make its people uniquely exposed. There is a psychological trap here too, and it may be the most dangerous of all. A great many people in the New Alley still carry the old mental map, the one from school, that puts tornadoes safely out in the plains. They think of tornadoes as a Kansas problem, an Oklahoma problem, something that happens to other people far away. That belief, comforting and outdated, leaves them slower to prepare, slower to take warnings seriously, and slower to act when the sky turns. Imagine a family that has lived in the rural South for generations, in a home without a shelter, never having drilled for a tornado, half believing such storms belong somewhere else. Now imagine the entire tornado machine slowly rotating toward them, delivering more storms in more months that they can barely see coming. That family stands at the exact intersection of rising danger and low readiness. And there are millions of such families. This is the human meaning of everything we have covered. The drought out west, the fever in the Gulf, the bending jet stream, the drifting boundaries, all of that abstract atmospheric machinery ends here, at the doorstep of ordinary people who never signed up to live in the crosshairs. The science becomes real in the form of a family in a mobile home on a dark December night, in a region that used to feel safe. The good news is that exposure is not the same as fate. Across history, the single greatest force in reducing tornado deaths has been human preparation and response. The people of the plains survived monstrous storms for generations because they knew the danger and were ready for it. The people of the New Alley can do the same if they recognize where they now stand. That recognition is the first and most important step, to understand that the map has changed, that the season has stretched, that the old assumptions no longer hold. A person who knows they are in tornado country behaves completely differently from one who thinks they are safe. Knowledge, in this case, is the beginning of survival. So the final question is the most practical one of all. If you are one of the millions now living in the New Alley, what do you actually do? How does a family, in this changed and dangerous world, give itself the best possible chance to live? Everything we have learned points toward a single hopeful truth. The storms have moved, but so can we. Survival is a plan made before the sky ever darkens. Start with the mind, because the deadliest belief is that you are safe. If you live anywhere across the Mid-South or the Southeast, accept that you are in tornado country now, in every season, day and night. A person who knows the threat is real acts fast when the warning comes. A person who thinks it belongs to someone else hesitates, and hesitation kills. Next, solve the problem of the night. The greatest danger in the New Alley is a warning that never wakes you, so do not rely on a siren meant for people already outside, and do not count on sleeping through a silent phone. Get a weather radio that sounds a loud alarm when a warning is issued for your area, and keep it by your bed. Let it be the thing that pulls you from sleep when the storm comes in the dark. That single device closes the deadliest gap of all. Then decide in advance exactly where you will go. If you have a basement or storm shelter, that is your place. If you live on a slab, choose the most interior room on the lowest floor, a bathroom or closet with no windows, with as many walls between you and the outside as possible. If you can, build or buy a reinforced safe room, the one form of above-ground shelter strong enough to survive even the most violent storms. And know this without flinching. If you live in a manufactured home, it cannot protect you. Your plan must be to leave it early, at the first warning, and reach a sturdy building or shelter before the storm arrives. Because time is so short here, plan your escape with the trees in mind. A single road can be closed by a single fallen tree, so never rely on just one route. Know several ways to reach shelter, and understand that once the storm is close, driving becomes a trap. The goal is to be sheltered before it arrives, not fleeing as it bears down. Practice the plan before you need it. Walk your family through the drill so that when the radio screams at 2 a.m, everyone moves without thinking. Do it before the spring peak, and again before the autumn one, because the New Alley has 2 dangerous seasons now, not one. And keep sturdy shoes and a helmet near your shelter, because so many injuries come not from the wind itself but from the debris it hurls, and a helmet can be the difference between a bruise and a fatal blow. None of this requires wealth or genius. It requires only that you take the threat seriously and prepare while the sky is still calm. The atmosphere has moved the danger onto your ground. Your answer is to be ready for it. The map you learned in school is gone. The storms have found new hunting grounds, in the dark, in the trees, in the crowded, unready towns of the American South. But you're not helpless before them. Know where you stand, wake to the warning, have your shelter ready, and never again believe the comfortable lie that tornadoes happen only to someone else. The alley has moved. Now it is your turn to move first. Prepare yourselves. Begin tonight.